Hello, and welcome to World of Warbirds. I'm Brian Pierce. The story of this warbird starts with the designer of the FW190. Kurt Waldemar Tank was born on 24th February 1898. Before we move on, can we all just acknowledge what a kick-ass name Kurt Waldemar Tank is? I don't know if it works better as a wrestler's name, a movie action hero, or a character from Harry Potter, but it really is an amazing name. When the First World War broke out, Tank had already had an interest in aviation and wanted to join the Imperial German Flying Corps. However, both his grandfather and father had been in the cavalry, and so Tank was convinced to follow in their hoofprints. So he was pressured to join the cavalry also. He finished the war as a highly decorated captain and immediately went back to school in order to get back to his original passion, airplanes. He earned his pilot's license and so became a real rarity, an aircraft designer who could test, fly the airplanes he built. In 1931, he became the design director and head of flight testing for Focke-Wulf in Bremen. He designed two highly successful training aircraft, the FW-44 and the FW-56, which were commercially successful because there was a lot of demand for new pilots in mid-1930s Germany. In 1934, Tank designed the FW159, which was entered in the competition for Germany's new fighter aircraft. Unfortunately for him, the FW159 was pretty much a disaster, and it finished last in the competition. Of course, the Bf-109 got the contract. Only a year later, the German Ministry of Aviation sent out a new request for another fighter to support the Bf-109. Tank decided that a whole new design philosophy was required. As an old cavalryman, he looked at the Bf-109 and the British Spitfire and decided that these two machines were like thoroughbred racehorses, the result of the mating of the largest possible engines to the lightest possible airframes. The resulting racehorses would perform well under pampered conditions. But Tank had seen horses in the trenches, and he knew that racehorses wouldn't last long under these conditions. Tank said, open quotes, "During World War I served in the cavalry. I had seen the harsh conditions under which the military equipment had to work in wartime. I felt sure that a quite different breed of fighter would also have a place in any future conflict. One that could operate from ill-prepared frontline airfields, one that could be flown and maintained by men who had received only short training, and one that could absorb a reasonable amount of battle damage and still get back." This was the background thinking behind the Focke-Wulf 190. It was not to be a racehorse, but a Zienfeld, a cavalry horse. Close quotes. Another design decision was that Tank decided to use a radial engine instead of an inline one, which was the usual choice for fighter aircraft at the time. A streamlined inline engine can present much less frontal area to the oncoming airflow and thus produce much less drag. But Tank had some good justifications for switching to the radial. He had the studies funded by the NACA in the USA in the 1920s that had led to the NACA cowling. This was a specially designed covering for the motor that actually consisted of a symmetric circular airfoil that is wrapped around the engine. It not only smooths the airflow, but also, as it is an airfoil, generates lift in the forward direction, counteracting drag. It also causes air to be sucked through the cowl, having the very positive side effect of keeping the cold, fast-moving air on the cylinder heads where it is most needed. Adding up these effects, and drag is reduced by almost 60%. Lastly, Tank realized that it was a really good idea to use an alternate engine to the inverted V12 Daimler-Benz DB601, which was already scarce and already being used for the Dornier DO215, the Messerschmitt Bf-109 and 110, and others. So Tank chose the radial engine and got to work designing his Zinnenfeld, or cavalry horse. So, a cavalry horse needs good legs, right? So for the new fighter, he wanted a strong, beefy undercarriage. He over-engineered the gear, giving it double the strength factor usually required, perfect for rough landing strips and less than perfectly trained pilots, slamming it down after a hard mission. He also made the gear inward retracting and wide-tracked, which would be much more forgiving for ground handling, especially when compared to its companion in arms, the Bf-109, which had narrow gear and were notorious for ground loops. To deliver snappy control and to reduce the amount of field maintenance and adjustment required, the new fighter was to be fitted with pushrod controls, which eliminated the control sloppiness and play that exists in aircraft with cable controls. There was a concerted effort to reduce pilot workload and allow him to do his main job, using the aircraft as a fighting weapon. Care was taken in balancing and lightening the controls to make flying this aircraft much less of an exhausting chore, and features were built in to reduce the amount of trimming that had to be done as the aircraft went from one speed and flight configuration to another. The elevator trim was electrical, as were many of the systems of the aircraft, as Tank determined that electrically powered systems were much more reliable and robust than hydraulic ones. Wires were much less prone to damage from enemy fire than a leak-prone hydraulic system. The landing gear would be raised and lowered by electric motors in the wings and was locked in place by electric stops. The guns were also to be charged and fired electrically. And now it was time to start building the new fighter, which received the designation FW190. Prototypes. The first two prototypes were powered by the planned BMW 139 14-cylinder two-row radial engine. And the very first 190, with the civilian registration D-OPZE, took to the air on the 1st of June 1939. Immediately there were cooling problems with the engine, which didn't bode well for Tank's gamble on using a radial, which had been really designed for use in bombers and transport aircraft and not fighters. Tank proposed installing an engine-driven fan behind an oversized hollow prop spinner with a hole at the extreme front, blowing air over the engine cylinders, with some of it being diverted through ducting over an oil cooling radiator. BMW one-upped this idea by deciding to build a whole new engine with Tank's proposals installed from the get-go instead of being jury-rigged on an engine that was already perhaps becoming dated. The result was the BMW 801. Other improvements were made, such as using sodium-cooled valves and a direct fuel injection system. It also had a single-stage 2-speed supercharger, which wouldn't be great for high altitude, but would be well suited to medium altitudes. At this point in the development of reciprocating aero engines, many controlled refinements were added in order to squeeze every bit of horsepower out of the fuel going into them. These included adjusting fuel-air mixture, boost pressure, supercharger gearing, chemical supercharging, water injection, fuel flow, and spark controls. To return to Tank's horse analogy, all of this would be fine for a racehorse with only one thing to do but goes fast. But all this workload would get in the way of a green pilot trying to shoot and not get shot. What if there was a way to automate some of this? There was. BMW came up with an electromechanical hydraulic analog computer that would be fed with various inputs, including air pressure and temperature, and would manage the engine and its subsystems. It was known as the Kommandogerät, which means command device. It had about 30 inputs and outputs and would relieve the pilot of having to regulate fuel flow, propeller pitch, supercharger settings, timing, and oil cooling duct flaps. The only thing he'd have left to control was the throttle. The results were good, and reports from the time stated that pilots indeed had an easier time flying the FW190 due to the Kommandogerät helping out with the engine management. Of course, everything in aviation is a compromise. With so much being automatically controlled, boost and mixture could not be manually tinkered with to deliver maximum range when cruising. This led to one complaint of higher fuel consumption. Another was that it was a very complicated unit, which meant that, unlike the rest of the fighter, it would make it difficult to fix and adjust in the field, and if it wasn't adjusted just right, it was prone to surging, which made formation flying even more difficult. Lastly, battle damage could lead to a complete loss of engine control, which was, bad. With the Kommandogerät helping to manage the engine, the pilot could focus on fighting, and for that, this Wolf had serious teeth. There were 2 guns in the fuselage and 2 in the wings. These weapons were synchronized with the prop as they were firing through the propeller disc. In the wings were 2 more guns, but these could fire freely as they were outside of the arc of the prop. Initially, all these weapons were machine guns, but later the wing roots and wing guns were swapped out for 20mm cannon. The aircraft was clearly a winner, and it was time to start building the 190 in earnest in Focke-Wulf factories in Bremen and a 99-acre facility in Marienburg. A total of 23,823 aircraft of all variants were constructed, including the 69 TA-152s, which were built very late in the war and were named for tank, and were an upgrade of the 190. Just to compare with numbers, 34,000 109s were built during the war. Once the 190 was introduced, it fought everywhere the German forces went, and in many, many different roles. So please check out part 2, where we look at the operational history of this butcher bird. Don't forget to subscribe.